Hello. I'm Bretton, one of our MCAT tutors here at Inspira Advantage, where we help students get into medical school and other professional programs. And welcome back to MCAT Bites. Today's episode takes a closer look at the concept of carrying capacity. We're going to trace its origins from Malthusian theory to its relevance in modern ecological studies. This is a weird topic for the MCAT because it's going to cover psych-soc and biochem. Let's jump into it. The concept of a carrying capacity has its roots in the work of Thomas Malthus, an 18th century English cleric and scholar. Malthus proposed that populations grow exponentially while resources grow arithmetically. And if you haven't heard what arithmetically means, it's just linear. Fancy way to say linear. Inevitably leading to a point where the population exceeds the resource arithmetic production. This would result in famine, disease, and other checks on population growth to bring it back down below arithmetic levels. Although Malthus himself did not use the term carrying capacity, his ideas laid the groundwork for understanding the limits of population growth in relation to environmental resources. Thankfully, we've avoided the grim future Malthus envisioned. Humanity has embarked on a series of innovative leaps, particularly in agriculture and medicine, that have significantly expanded the carrying capacity for humans. The agricultural revolution, followed by the Green Revolution in the mid-20th century, introduced high-yield crop varieties, synthetic fertilizers, and advanced irrigation methods, drastically increasing food production rates. On the medical side, the advent of vaccines and antibiotics improved health outcomes and life expectancy, allowing populations to grow without the proportional increase in mortality rates that Malthus predicted. We can live in cities without dying from disease. These advancements, along with improvements in public health infrastructure, have enabled the human population to sustain a growth trajectory that Malthus did not foresee, effectively delaying or mitigating the impact of reaching the carrying capacity he anticipated. While Malthus' predictions have not come to pass in the stark form he imagined, his work remains foundational as a contribution to the fields of demography and ecology, reminding us that the delicate balance between population growth and resource availability. It underscores the importance of continued innovation and sustainable practices to manage the relationship between human populations and Earth's carrying capacity for us. And when it comes to animals, they're probably not going to invent better agricultural methods. So it is a lot more relevant for animal populations that aren't humans. In contemporary ecology, carrying capacity is defined as the maximum number of individuals of a species that an environment can support sustainably. Unlike the Malthusian focus on catastrophic outcomes of overpopulation, modern interpretations consider technological advancements, conservation efforts, and sustainable resource management as factors that can modify an environment's carrying capacity. This perspective acknowledges that carrying capacities are not fixed and can change with human invention and environmental changes. Now, let's look at a little bit more math, because the MCAT loves to ask this question. The logistic growth model incorporates the concept of carrying capacity directly, showing how population growth rates slow as population size approaches the environment's carrying capacity, shown here in a dotted red line. This leads to an S-shaped curve, or a logistic curve. This model offers a more nuanced understanding of a population dynamics than Malthus' original theory, accounting for the natural regulations of mechanisms within population, such as predation, disease, and a potential lack of food. But what are the human applications here? So applying the concept of carrying capacity to human populations raises complex questions about sustainability, resource consumption, and environmental impact. Modern discussions often focus on reducing resource waste, improving efficiency, and stabilizing population growth to maintain balance with the Earth's carrying capacity. The evolution from Malthusian theory to modern ecological understandings of carrying capacity highlights the complexity of managing population dynamics within the limits of environmental resources. As we face global challenges of sustainability and conservation, the concept of carrying capacity remains a critical tool for our ecological and social planning. Through this exploration, we gain a deeper appreciation for the historical and contemporary significance of carrying capacity in understanding and managing population dynamics, which will be very helpful for getting you a few more MCAT points on that very important exam. So stay tuned to MCAT Bytes for more insights into essential biological and ecological concepts. Thank you so much for watching our video, and I will see you next time.